A road can fail before the first vehicle ever uses it, not because of poor design, not because of bad materials, but because one factor was underestimated: weather. Weather silently decides whether a road project succeeds, or turns into delays, cost overruns, and premature failure. My name is Engineer Hamza, civil engineer, highway construction specialist, and researcher. If you're a student, an engineer, a contractor, or a project manager, stay with me, because what you'll learn here is how professionals think on site. In this video, I will explain how weather controls site access, productivity, safety and pavement durability, the effects of rain and heavy precipitation, the impact of hot and dry weather, how cold and frost weaken pavements, why wind and dust are dangerous, how storms shut down projects, the advantages of good weather, the disadvantages of bad weather, practical recommendations used by professional engineers, and a short checklist you can recall instantly, even in exams. Stay with me, because every point here carries real engineering consequences. Weather controls site access, earthwork productivity, material behavior, worker safety, and the quality and durability of pavement works. Poor weather delays schedules, increases cost, causes rework, and creates unsafe conditions. Favorable weather speeds work, improves compaction, and enhances laying quality. So, rain is honestly the most disruptive weather condition in road construction. It can cause flooding of excavations and borrow pits, and you might see ponding on working surfaces. Saturation of soils leads to a loss of shear strength, which is a big deal. There's also pumping and rutting under equipment, reduced compaction efficiency, and contamination of aggregate and bituminous surfaces. Plus, erosion of exposed slopes and stockpiles can become a real headache. Aggregate contamination happens when clean aggregates or prepared surfaces are, exposed to water, mud, clay fines, or dust. Bitumen actually relies on adhesion to bond layers together. If the surface is wet or dirty, the bitumen just can't bond properly. What you end up with is poor interlayer bonding, slippage cracks, stripping and peeling, and even premature pavement failure. The road might look fine on the outside, but it's already failing internally. Now, let's talk about consequences. There are delays while sites dry, the need for dewatering and silt control, increased compaction effort, and sometimes the replacement of saturated material. For mitigation, good temporary drainage is essential, along with berms and diversion channels, silt traps, covering stockpiles, and if possible, scheduling earthworks during drier periods. All these steps really help minimize the impact of rain on construction. Alright, so, when we're dealing with high temperatures and hot, dry weather, there's some stuff you really need to watch out for. Rapid drying of subgrade and aggregates happens, which, honestly, can be good for compaction, but only if things don't get over dry. Now, for asphalt, these conditions actually improve the workability of hot mix and allow for quicker curing, which is pretty convenient. But for concrete, there's a risk of rapid evaporation, and that can lead to plastic shrinkage, cracking, and bleeding. Definitely something you want to avoid. The consequences here include a need for dust control and hydration management for concrete, plus possible thermal distress in fresh asphalt, and really short compaction windows. So, what can you do? Well, watering and spraying for dust control is a must, and sometimes you might need sunshades. You should also consider adjusting the mix temperature and your compaction schedule. And for concrete, using curing compounds is really helpful. When cold weather hits, or you get frost and freezing, things get tricky. Freezing of soil poor water leads to frost heave, and when it thaws, you can lose strength in the ground and end up with rutting, especially if you're dealing with frost-susceptible soils, which are a real headache. Concrete cures at a much slower rate, and if asphalt cools too fast, compaction gets restricted. The consequences? Well, sometimes you just have to halt certain operations, use insulation or thermal blankets, and deal with scheduling difficulties. To mitigate these issues, you can use ground heating, switch to frost-resistant materials, delay paving until temperatures are better, and minimize the exposure of fine materials. And, when it's windy or really dusty out there, blowing dust can seriously reduce visibility and air quality, and it can contaminate the surfacing too. You might also run into problems with sprayed bituminous operations. The consequences include health and safety risks, and, honestly, increased dust suppression costs. To deal with this, you should use water sprays, set up windbreaks, and try to schedule sensitive activities during calmer periods whenever possible. So, during storms or extreme weather, well, sometimes we have to shut down the site for safety. There's also the risk of damage to temporary works and, erosion and siltation can become real issues. The consequences, we're talking about major delays and, possibly, repair works that need to be done. To mitigate these problems, we rely on robust temporary works, solid emergency plans, and, honestly, a bit of flexible scheduling goes a long way. Now, let's talk about the advantages of good weather. Higher productivity since there are fewer stoppages, you get improved compaction and material placement, better quality control, and, fewer reworks. It's also safer for everyone on site, and logistics, as well as site access, become much easier. On the flip side, bad weather brings its own set of disadvantages. You can expect delays and increased costs, reduced workmanship quality, and, unfortunately, environmental problems like sediment runoff and pollution. There are also safety risks, such as slippery surfaces, reduced visibility, and storms. Plus, material losses can happen, like washed-away fills or contaminated aggregates. So, here are some practical recommendations for professional practice. First, always plan by season. Make sure you provide temporary drainage and erosion control, and protect those stockpiles. Manage site access carefully during wet periods. After any adverse weather, conduct moisture and density testing. Don't forget to include some contingency time and budget. Use appropriate materials for extreme conditions, and of course, implement strong health and safety plans. Here's a short checklist for exam and field recall. Rain leads to saturation, erosion, and delays. Heat means faster curing and a higher risk of cracking. Cold or frost can cause strength loss when things thaw. Wind brings dust and contamination. So always plan, protect materials, and test after any of these events. If you're a contractor, project manager, or organization, you now understand why weather-smart engineering separates successful projects from failed ones. I'm Engineer Hamza, civil engineer, researcher, and YouTube educator. I'm open to project supervision, highway consultancy, technical advisory roles, and professional training. If you value precision, planning, and engineering excellence, feel free to reach out. Like this video, and subscribe for more professional engineering insights. Remember, a road doesn't fail suddenly. It fails when engineers ignore the details.